So hi guys, your boy Jibob back and active here. In this video, I'm going to be solving questions on physics 103, past question on physics 103. This is the first video I'll be making. So let's dive into the video. Question number 1. To download the questions, just check the description below this video. You download the questions there and you solve it with me. I have a copy on my phone. So question number 1. Let's go into it directly. They said, determine the change in the internal energy of a 2 mole of polyatomic gas kept at 27 degrees Celsius. We are looking for the internal energy of a polyatomic gas, and they gave us the mole, which is 2 mole. They gave us the mole, which is 2 mole, and they gave us the temperature, which is 27 degrees Celsius, and 27 degrees Celsius is 300 Kelvin. 300 Kelvin. So they said we should look for the internal energy, and we all know the internal energy is also equal to NCV change in T. Notice this thing is change in T. This is the formula we're going to use. But if you read the question well, they said determine the change in internal energy of a 2 mole of a polyatomic gas kept at 27 degrees Celsius. That means the temperature is constant because it was kept at 27 degrees Celsius. The initial temperature is 27 degrees Celsius and the final temperature is 27 degrees Celsius. So when we have change in T, that will be 27 minus 27, and that is 0. So 0 times everything here will be 0. And the answer is option A. So let's assume you didn't read that question very well. You are going to solve it, put 27 degrees Celsius, put 300 Kelvin, and you get your answer, and the answer will be in the option. But if you read it well, you would have seen that it's 27 degrees Celsius, kept at 27 degrees Celsius, which means temperature is constant and change in temperature is 0. Question number 2. They say which of the following is correct about absolute zero temperature? The absolute zero temperature is 273.15 degrees Celsius. You know that one is wrong because absolute temperature is minus 273.15 or 0 Kelvin. 0 Kelvin or minus 273.15 degrees Celsius. So I is wrong. They said the absolute zero temperature is 273 Kelvin. It's also wrong. The absolute temperature is 0 Kelvin. Is correct there. IV, the pressure at absolute temperature is negative. The pressure at absolute temperature is 0, while below absolute temperature is negative. So that option is also wrong. And the last one, they said the pressure at absolute zero temperature is 0. That's V. So the correct option is I and V, and that's option D. Question number 3. Question number 3 says the temperature of 2 objects in 2 different environments were measured on a Fahrenheit scale on a particular day. If the temperature difference of the 2 objects in Fahrenheit, then change in temperature in Fahrenheit is 70 degrees Fahrenheit. Determine the temperature difference in Celsius. So they are asking you to find change in temperature in Celsius. And we all know you just use this formula. Change in TF is equal to 9/5 change in TC. So if change in TF is 70, and 70 is equal to 9/5 change in TC. And when you find change in TC, that will be 70 times 5 divided by 9. 70 times 5 divided by 9. Now change in TC is equal to, what is the calculator? 70 times 5 divided by 9. 70 times 5. 70 times 5. That's 350. 350 divided by 9. That's 38.8 degrees Celsius. 38.8 degrees Celsius. And that's option B. 38.8 degrees Celsius. So that's 38.8 degrees Celsius, and that's option B. Question number 4. They said the electrical resistance of a platinum thermometer at the lower and upper fixed point of water on a Celsius scale is, the lower fixed point is 15.5 ohms, and the upper fixed point is 17.8. 17.8. Then they asked us to calculate the temperature when the resistance is 16.7. When the resistance is 16.7 ohms. So what we just do is we compare it to the Celsius scale. The lower fixed point of the Celsius scale is 0 degrees Celsius. The upper fixed point is 100 degrees Celsius. So when this one is 16.7, what is the temperature in Celsius? So anything we do here, we have to do it here. So let's say this will be 16.7 minus 15.5 over 17.8 minus 15.5 is equal to x minus 0 is x over 100 minus 0 is 100. So just do this one on the calculator. So 16.7 minus 15.5, that's 1.2. That's 1.2 over 17.8 minus 15.5. Now this one is 2.3. Equal to x over 100. Then just make x the subject of the formula. That's 1.2 times 100 divided by 2.3, and that's 52.17 degrees Celsius to 2 decimal places. That's question number 4, and the answer of option C is 4.3. That will be the answer. So let's go with question number 5. They said which of the following is or are correct? So we all know that gamma, that's cubic expansivity, is 3 times linear expansivity, and area expansivity is 2 times linear expansivity. So if you see this kind of questions, we just want to test the one that is correct. So they said gamma is 3 alpha. That means that one is correct, because that one is correct. So I is correct. I says beta is 3 times gamma divided by 2. So let's test that one. Since beta is 2 gamma, and here you can say 2 alpha, and here you can say alpha is equal to gamma over 3. That means beta is 2 gamma over 3. Then you plug this one into this. So they said beta is 3 gamma over 2. No, it's 2 gamma over 3. Beta is 2 gamma over 3 is correct. So is also correct. IV, gamma is 2 beta over 3. Gamma is actually 3 beta over 2. Because when we turn this one upside down and we make gamma the subject of the formula, it will be 3 beta over 2. And the last but not the least, they said V, alpha is 2 beta. Alpha is 2 beta. No, that one is not correct. So our final answer is I and I, and that was option D. So let's check this question 6 and 7. They said the active element of a certain laser is a glass and is 30 centimeter long. That's the original length. The original length is 30 centimeter. And the diameter is 1.5 centimeter. That's the diameter. The diameter is 1.5 centimeter. They said if the temperature of the rod decreases by, that is change in temperature, if it decreases by 65 degrees Celsius. Question 6 now says calculate the new length of the rod after the temperature change. So we are going to look for L2. So this kind of question we are going to use linear expansivity, but we don't know the linear expansivity of glass. But when I find out the linear expansivity of glass is 9 times 10 raised to the power minus 9. That's the linear expansivity of glass. So just plug it into this equation. L2 linear expansivity is equal to L2 minus L1 over L1 times change in T. And just look for the subject of formula. Gamma is 9 times 10 to the power minus 9 is equal to L2 minus 30 centimeter over L1, that's 30 centimeter times 65, change the temperature. Then you make L2 your solid formula. So you just multiply this one. 9 times 10 raised to power minus 9 times 30 times 65 plus 30. That will be 30.000018 centimeter. And if you look at the option, that will be the answer will be 30.02 centimeter. Why our answers are separate is because the linear expansivity of glass varies it has a range of values. So it can be 9.0 10 times 10 minus 3, it can be to 10 to the minus 9. It depends on the kind of glass. But here they didn't give us the linear expansivity of the glass. But in your test, they are going to give you the linear expansivity of the glass to use. So to determine the volume, that one is straightforward. That's question 7. Question 7, to determine the volume, you just have to look for the volume expansivity, and that will be 3 times the linear expansivity, which is 9 times 10 raised to power minus 9. So we use this formula. Cubic expansivity is equal to V2 minus V1 over V1 change in T. So after doing that, you find the volume of the glass rod, and we know that a rod is cylindrical, and volume of cylinder is pi r squared L. So you find this one too, and after finding this one, you plug it into this equation and solve it. Or there's a faster way to do it. You can still use linear expansivity and just take the diameter as take the diameter. You take the diameter instead of the volume and solve it. But just use this way and you get your answer. So question number 8. This one is a logical question. It says, which of the following statements are not correct? Which one is not correct and which one is false? Always take note of the not correct and which one is correct, which one is not correct. So here they said, in an isolated system, internal energy is 0 because heat and work done is 0. In an isolated system, internal energy is not 0. Internal energy is constant. It's change in internal energy that is 0. You should know that. So in an isolated system, internal energy is not 0. That means I is not correct. That means I is part of our answer. In an adiabatic process, the internal energy is 0 because there is no exchange of heat between the system and environment. In adiabatic system, there is no exchange of heat, but internal energy is not 0. The internal energy is not 0. So II is also not correct, which is part of our answer. In a cyclic process, change in the internal energy is 0 because work done is 0. In a cyclic process, change in internal energy is actually 0, but not because work done is 0. Work done is not 0 in a cyclic process. It's only change in internal energy that is 0, which means III is also correct. So you need to know how to read all the information before you decide your answer. IV, they said initial and final internal energies are the same in an adiabatic process. What this one is saying is internal energy is constant. In an adiabatic process, internal energy is not constant. So IV is also, in an adiabatic process, it's just Q that is 0, and the internal energy depends on the work done by the system or on the system. So internal energy is never 0 or never constant. And number 5, he said isochoric process is also known as isovolumetric process. Yes, that one is correct. So it's not part of our answer. So our answer is I, and IV. And that is option A. The fastest way to answer questions like this, you just look for the correct one. They say you should find the not correct, so we'll look for the correct one and we'll use it to eliminate some options. So As we found out that V is our correct option, we can just look at where there's V and remove that one, and where there's no V, that's our answer. Question number 9. They said, how many rotational degree of freedom have the molecules of nitrogen gas? The answer is 2. The degree rotational of freedom of nitrogen gas is 2. Question number 10. Which of the following are not correct? Then they gave us the values of all the formula for all those adiabatic expansion. And you need to know all these things. Maybe you should know how to derive them, or you should know them offhand. It depends on you. You need to know in adiabatic expansion or compression, PV is power gamma. You need to know this one. You also need to know this one. This time we are dealing with comparing pressure and volume, comparing temperature and volume in adiabatic process. You also need to know this one. You also need to know this one. So these are the three ones. I need to know the one for work done. Our work done is equal to 1/1 minus gamma P1 V1 gamma bracket V2 minus V1 raised to power 1 minus gamma 1 minus gamma. So you need to know all these things offhand. So they're asking us which one is not correct. They said I is P1 V1 this is equal to P2 V2 this. This one is correct because it corresponds with this one. This same means what we have here, It's just 1 here, 2, 2. I said T raised to power 1 minus gamma. That one is only incorrect because there's nothing like T raised to power 1 minus gamma here. So I is correct. So let's just use I to eliminate some options. That's D is not part of our option. I. Let's check IV. IV is correct. So our answer, looking at everything, our answer is going to be C. Our answer is going to be C, I, and I.